I think we're nearly there now.
Fair enough.
Yeah, we're there. So just to say, everyone, again, apologies for the delay. I'd like to welcome you all to this evening's session. My name is Sean.O'Brien and I work with the Confirm Centre. So Confirm is a Science Foundation Ireland funded research centre for smart manufacturing based in the University of Limerick in Ireland. So I'll give you a bit of an overview of Confirm in a few minutes. But I'd just like to say on behalf of the centre, this is our first event that we ran as part of Berlin Science Week and we're really delighted to be involved. So I'd just like to welcome you all to the session and thank you for attending. So just before I introduce you to the panel, I'd just like to give you a brief overview of Confirm. So as I said, we're a Science Foundation Ireland funded research centre. We're based in the University of Limerick, but we span across 9 academic institutions in Ireland, 3 of which are represented on the panel today. And we currently have just over 170 researchers carrying out both basic and applied research in the areas of smart manufacturing and Industry 4. So our discussion today is going to focus on those 2 areas. So in terms of research, we have a strong industry focus. We work on several collaborative projects with industry partners to apply smart manufacturing technologies in Industry 4 to enhance manufacturing processes from supply chain right through the production process. And we also have a very strong education and public engagement remit in the centre. And this kind of aims to enhance public awareness of STEM research in general, again, with a particular focus on smart manufacturing. So the discussion today is kind of going to focus on both of those topics, both the technology and the wider societal impact of that technology. So I suppose without further ado, I'd like to introduce you to our panel. So first up, I'd like to introduce Professor Barry O'Sullivan. So welcome, Barry. We're delighted to have you today with us. So no problem at all. So Barry is an academic based in UCC, which is University College Cork in Ireland. And he's working in the fields of artificial intelligence, constraint programming, prescriptive analytics, in operations research, ethics, and public policy. So Barry was appointed Vice Chair of the European Commission High-Level Expert Group on AI in 2018. And in 2020, he was elected a member of the Executive Council of the Association for the Advancement of Artificial Intelligence. And so Barry's also a principal investigator in Confirm. So again, welcome, Barry.
Thank you, Sean.
Next up, I'd like to introduce Dr. Rupal Srivastava. So Rupal is currently a Marie Sklodowska-Curie Fellow with a co-fund called Smart 4.0, based in Confirm as well. Rupal is based up in Athlone, what was formerly known as Athlone Institute of Technology, which is now the Technological University of the Shannon. So Rupal completed her PhD in solid mechanics and design from the Indian Institute of Technology in Kanpur, where she worked in active composites and smart materials. So at the moment, Rupal is working on memory alloys and their integration into smart wearables, digital twin, and manufacturing pilot line. Rupal is also, on the other hand, an investigator in a new project that we're starting in Confirm, looking at the social impact of smart manufacturing in Industry 4. So welcome, Rupal.
Thank you for having me, Sean.
No problem. And finally, last but not least, I'd like to introduce Professor Martin Hayes. So welcome, Martin. Martin is a professor of digital technologies, and he's also the academic lead for the UL at Work project, which again is based in the University of Limerick. So this project supports workplace-based education and upskilling for Irish industry in the areas of smart manufacturing, cybersecurity, and the use of extended reality for operator training. So Martin is also a funded investigator at Confirm, and his research applies systems dynamics, conversational AI, natural language processing, deep learning, and visual cognition principles to foster improved operator practice and to better characterize the manufacturing processes that are resistant to automation. Hope I got all those correct for you.
John, I feel I should have put a comma in there somewhere for you. Sorry about that.
Not at all. Maybe I should have put it in myself, Martin. But just to welcome you all today, guys, we're delighted to have you on the panel for this discussion. So, excuse me, just before I kick off for the audience, so there is the Q&A function is open, so I'd encourage everyone to enter questions in that as we move into the discussion in a second. And we'll get the panel to answer those for you as we progress through the discussion. So I suppose to kick off the main aspect of this session, I'd just like to get the insights of the panel on the impact, I suppose, the technological advancement has had during what was so far, I suppose, in the fourth industrial revolution. So Barry, I might go to you first, if that's okay.
Great. So, where have we got? I suppose, how have we got here? Do you think, or something more than that? Sean.
Yeah, I suppose how have we gotten to where we are today? I guess.
Well, today is the birthday of George Boole, I should point out. Obviously George Boole was the father of symbolic reasoning and automated reasoning to some extent, and his work started off, well, to some extent, the journey to artificial intelligence and so on. I think fast forwarding 150 years, his great-great-grandson picks up the baton and invents deep learning, Geoffrey Hinton. And I suppose over the last 15 years, there have been tremendous advances in all things related to sensing and data and artificial intelligence, as a consequence of the standard narrative, which I think is true, that we're now gathering huge amounts of data. We have great computational resources, and we have techniques that can do interesting things. And obviously in manufacturing, maybe more than many other areas, huge amounts of data are being gathered. You often hear manufacturing engineers saying that they're gathering so much data, they actually don't even know why they're gathering it, but they can gather it because the machines actually produce it. So, and I think, there's been huge advances in AI and data gathering and everything else. And I suppose we're starting to see the real benefits and opportunities of using that kind of data in smart manufacturing, and the whole set of revolutions, fourth and fifth and all that kind of thing, sort of shows the evolution of the thinking to, bringing robots and cobots and, onto the shop floor and have them working beside humans, then the trustworthy dimension. So, it's been an amazing journey. But I suppose one that, obviously this event is Berlin Week, Berlin Science Week. And I think what's really interesting is that, there's this narrative around that Europe is sort of falling behind in AI and these types of technologies, as compared with the US and China. But I don't think that's true. And I particularly don't think it's true in the context of smart manufacturing and AI for smart manufacturing. I think Europe is probably the leader in those areas, and I think Germany in particular is one of the leaders in these areas. If you look at engineering applications of AI, you will hear many German brand names. You'll hear many household names there, and I think if they're not German names, then they are European names. So I think we've had a long history and a very strong European history, and it's something we should be really proud of.
Great,
thanks.
Perfect, thanks, Barry. So I suppose, Rupal, just to get your insight on that opening question there. So the impact, I would say, that technological advancement has had as a result of Industry 4.
Like Barry said, that it has been a continuous development, and there have been many revolutions. We started with the first industrial revolution, then we came to the second when we had electricity, and then when we started with the automation, we had computers. So when we think about CNC machines or G codes and M codes, we think about the third industrial revolution. And now what happened was that now we had AI, we had machine learning, we had all these tools with us, and then integrating them. We had robotics, and then we integrated that with manufacturing. And that's how that automation in manufacturing became more and more smart. So we came to smart manufacturing, we have smart industries, we have smart cities. So that was the Industry 4.0. And now that we are evolving as a society, we are becoming more and more inclusive. We are bringing in users into the design. So we are bringing in their opinions. So now the consumer, the customer, is becoming the designer as well. So that's how we are now moving towards Industry 5.0, so that the craftsmanship, which we were apparently losing because of the mass production, should come back. So we are bringing humans back in the automation and manufacturing. So that's how we have come to this point. And in my opinion, I think that automation is very, very important. And how I can say is that when I was doing my PhD in around 2017, I was fabricating smart composites, and I had e-glass fiber reinforced composites, and I was using the hand layup technique to make these. And I observed that after I would complete the process, the entire experiment, I would observe that I had glass fibers all over me. So even though I had the safety gear on, so it was on my mask, on my coat, on my gloves, everywhere. And I would just think that I can't imagine if there is someone in a factory somewhere who has to work with these glass fibers day in and day out, and that's their job. So if 2 hours of me working on a composite, let's say twice a week, that's causing so much trouble, imagine. And then I went and looked at the statistics. Yes, people who are working in these kind of industries and hazardous environments, they get lung cancer, they get asthma and several other such diseases. So automation in these industries is really important, it's vital. It's important to remove humans from risky environments and hazardous environments. And that's how Industry 4.0 and in future Industry 5.0 is going to cope that kind of a problem. And even when we talk about these days of sustainable manufacturing, we see that we have robots with the spectroscopy, and they can really sort materials into what could be recycled and what could not be, which humans can't do. So in these all aspects, I think that these technological advancements are not just improving the quality of production, they're also improving the quality of life. So yeah, I mean, that's my opinion on smart manufacturing currently.
Great. Thanks a million, Rupal. I suppose just to, Martin, just to get your input on that question as well. So what has been the impact, I suppose, of Industry 4? Maybe looking at it from your point of view in terms of, the UL at Work project, in terms of skills needs and training and things like that.
I suppose the question is, what hasn't been the impact really? I mean, particularly, as Barry and Rupal pointed out, I mean, in manufacturing specifically, it's not really a question of, how computers, data engineering, artificial intelligence, and just general smartness has changed manufacturing. It's more a question now of the choices that we make in terms of the new directions that we go, the new products that we make, how we're going to apply machine learning and artificial intelligence in this ethical, trustworthy way that actually helps humankind. And that's where Industry 4 and Industry 5 are going to, that's where the interface is, right? It's now, we have choices to make. As Barry correctly points out, we have more sensors, more data than ever before, more sensors really than we know really what to do with and actually take, actionable intelligence on. I mean, any systems theorist will tell you, if you've more sensors than you have actuators, then you've got a problem, because you have to actually choose which sensors are the most important ones, right? And that notion of fusing all that data together in an intelligent fashion, in a smart fashion, and in a trustworthy fashion, which actually helps humankind, is the challenge that faces all of us as researchers. And it's very interesting, particularly, as you say, it being German Science Week. I mean, we look at the supporters of Confirm and the supporters of Irish industry in general, and how Germany in particular has contributed to the development of Irish society. The family-run businesses like the Bosch, like the Festos and the Costals of this world, and then the multinationals like the Bosches and the Siemens, who are all good employers here, and who Irish people kind of have raised families and have just developed our society on the basis of that kind of German influence on our society. So it's, as you say, it's been a uniformly positive thing for Irish society and European society. So long may it continue.
If I could just add one more thing, I suppose, and when we were chatting earlier in the week about this panel, people talk now about Industry 5.0, and I think I'm not quite sure we've sort of gone to the Industry 4.0 thing quite yet. We shouldn't get hung up on the labels, like what's 4, what's 5, what's 3.7, or the rest of it. I think the important thing is that we're ensuring that the technology from artificial intelligence and from analytics and robotics has been used in a way that is adding value on the one side, but also just trustworthy AI, trustworthy technologies, critically important, and the human in the loop and on the loop and all that stuff is critically important. But we can't lose sight of the fact that these technologies also they create economic efficiencies, and we need to make sure that everybody benefits from those efficiencies. And so the rising tide raises all boats, rather than the boats of the factory owner who's doing very, very well, but that's public policy and things like salaries and all that sort of stuff are moving along with it.
Absolutely. And it's funny you said that, actually, Barry, because I was at an event yesterday, and somebody started, it was actually an in-person event, which is lovely. It was a nice change from the virtual ones that we've become very used to. But one of the speakers started mentioning Industry 5, and the thought actually crossed my mind, have we actually finished with Industry 4 yet? But I think the point you made there about maybe not relying on labels so much is a good one.
I mean, it's an interesting question from the perspective of how people upskill whilst they're at work, and how people retool in terms of what are the skills that will make people useful contributors to society going forward, right? And these are not straightforward questions, right? I mean, this notion of skills pivots and how you pivot from one role to another within a company, and the training and education that you need in order to do that.
Exactly. Yeah.
That could be a job in itself. Actually, what skills do I need moving forward? And what will stand to me for 10, 15, 20 years? So it is our responsibility as educators, as researchers, but also as academics, to try to help provide people with that roadmap, with that pathway that they feel confident in the choices they make, right?
Yeah, so if we say that we are going to have another industrial revolution, the Industry 5.0, so there has to be also an education revolution. So there has to be a major shift in the way we have been training our professionals. So there are diplomas for people who are going into manufacturing sectors. Why not have more diplomas and more short-term courses for people who can then get employed working in the R&D with AI, with ML, with robotics? So yeah, we need both going hand in hand, the revolution in education as well as what's happening in manufacturing right now.
And to be honest, it's something that we see a lot as well in my kind of work with teachers, and you even at third level, like, are we actually educating the kids of tomorrow, I suppose, or the workers of tomorrow appropriately for the skills they might need? So it's definitely something that's on the minds of people, even down to the second level education, in Ireland anyway.
And this is one of the reasons why we probably need to be careful about introducing new labels. I come from a computer science background. We're very good at introducing new labels, and my first degree was in manufacturing, and we're awfully good at introducing new labels in manufacturing. And there is a cost associated with that, which is creating sort of stress amongst particularly SMEs and so on about are we doing Industry 4.0 correctly? Oh no, not does an Industry 5.0. God Almighty, we're way behind. But also the kind of stuff that Martin is doing with the education, like, it's very important that that young people, and indeed people at all career stages, are not frightened off by what they perceive as a sort of an ever-moving target. That there are fundamental sort of strong skills that people need, and it's important that they get those, and that these labels, they are meaningful, but they're meaningful almost on a different kind of on a different axis.
Yeah. I mean, you look at World Economic Forum reports, OECD reports. What are the things that are going to be in demand in 2025 or 2030 or 2040? It doesn't change. Good problem solving skills, good ability to work in teams, good soft skills, communication, interpersonal skills. These things don't change. And as you say, I always, there was an old slogan that a colleague of mine always used to put on: "Don't get phased by TLAs."
I think I'm going to use that one again. Rupal, there was something you mentioned a minute ago that I just wanted to pick up on, when you were kind of giving your insights into the impact, I suppose, of Industry 4 to date, and you mentioned sustainability and maybe an environmental impact. Could you just go into that in a bit more detail, maybe?
So now that we have robots integrated in automation, and we have in our Industry 4.0, sorry for using the label, sorry. But yeah, I mean, so not just, so as I talked about, not just about the the sorting of the trash or the materials which is usable and which is not. So there are companies, I won't be naming any companies, but there are companies which are reusing almost all of their products. So once you are done using their electronics, you can send it back, and then they are building new phones or new laptops with the laptops and phones that they have already received. So it's interesting, and this job cannot be done by humans because the parts, the electronic parts and the chemicals that are used, they cannot be handled by workers, or we shouldn't be putting workers into that kind of a situation and that kind of an environment. So reusing has increased. So that is one aspect of it. And because using robots and machines in manufacturing, we can get very precise designs. We can achieve low wastage. So we are reducing a lot of waste because there is no material waste in the process. So that is one aspect. And then in between breaks, so I was reading this in an article that in between breaks where the workers are not using the robots, there are other robots which are tending to the machines, kind of the maintenance part is done in between the breaks. So we are also saving on energies. We can also use these machines during the nighttime so that there is less, Martin and I were discussing that day, that there is no impact on the grid. So there are so many ways in which Industry 4.0 can, again, sorry for using the label, I'm so used to it. It is impacting with the sustainable development. And then, so the domain is so large. It's not only focused towards the manufacturing. Industry 4.0 also goes into smart cities. And then there are robots which are helping with planting the trees. There is this robot by Stargrow, or there is a company. And so it's called Growbot. And it can plant trees 10 times faster than humans and at half the price. So that's what we need. We need more and more robots which are taking care of the environment, which are bringing more and more better quality into the world.
I think the important point to make, Rupal, as well, is that there aren't the humans around at the moment to actually plant these trees. So it's not exactly that we're putting anybody out of work here. You know?
I suppose one of the interesting things about the whole industry X.0 thing is I think it allows us to start rethinking sort of our supply chains. What surprised me recently, I've just finished building a house, and I was talking to the builder recently, and he was telling me that there's a global shortage of screws. There's a global shortage of nails. How can there be a global shortage of nails? And the reason that I looked into this, and apparently the reason there's a global shortage in things like nails and screws is that nails and screws are invariably made in huge factories in China. And because of supply chain issues, it's been very, very difficult to distribute them. And I think what we've learned during COVID, for example, is that global supply chains are very, very brittle. I'm sure anybody who's tried to buy a computer recently is probably waiting for many, many weeks. I've been waiting for 2 months for a keyboard. So I think one of the great opportunities from a sustainability point of view of these smart approaches to manufacturing is that it allows countries to really think about their own sort of resilience and in terms of supply chain, and to what extent they can countries can reconfigure those product lines that are running in their countries to produce items that might be sort of core to the mission of just keeping the lights on. And I think the combination of global pandemic and Industry 4.0, 5.0 is that it shows that there is another way of doing things, and I think we should take that opportunity very seriously, because I think if we continue to sort of globalize supply chains, because in response to cheap human labor, I think we're really doing the world a disservice. And if we learn anything from the COVID pandemic, is that that is just not a robust way of doing things. If we can't build things in a country because we can't get the nails and screws and hammers from other parts of the world, I think that's a very strange place to be in.
Yeah. And it's interesting. I mean, and just to amplify the point that you made at the start, Barry, particularly in relation to whether Europe is falling behind or not, and this furrowed brow that people have all the time about, well, where we stand in world terms. One of the real good things that you encounter when you're kind of putting together kind of consortia to apply for kind of European funding and things like that is that Europe does actually take its place in the world very seriously, and the whole notion of kind of onboarding manufacturing back onto Europe, because first of all, the idea of outsourcing manufacturing was not good for a number of ethical reasons, but also wasn't great for the planet in terms of actually, the cost in terms of importing all these materials and supply chain thing in from the Far East, wherever, was generally never, a full economic costing of that was never done. And, if we start from a position that, for example, data engineering, machine learning and data gathering is now at a stage where we actually can properly work out the full cost of actually making things, transporting things, and actually putting them in people's homes, then you can actually ask sensible questions about where we should be making them, who should be making them, and how we should be making them.
And that's where the role of digital twins come in, because we need digital twins of all these processes so that we can figure out what's the most effective method and how we can achieve it without offshoring the jobs. We have to reshore them. Yeah.
I think actually, guys, there's a question that just came in from a member of the audience that kind of relates to this. So I might just put that to you now. So it's from Henry. So Henry would like to know if and to what extent Industry 4. Sorry again, I'm kind of paranoid now about using the label, but so we'd like to know if and to what extent Industry 4 is impacting countries that are not seen as the main industrialized places in the world. So can we use the concept of Industry 4 and the advancements that come along with it, I suppose, to accelerate people getting out of extreme poverty? It's a good question.
Yeah, well, maybe I'll just say something quick on that one. Give the others time to come up with something really interesting to say, as opposed to what I'm going to say. But I think we have to be careful about Industry 4.0. This thinking about manufacturing is excellent, right? But those that are poorest in the world, half of the world's population doesn't even have access to the internet, doesn't have access to phones, and so there's a lot more work has to be done amongst that sort of, let's say that lower tier in terms of wealth. To get them out of that kind of situation. And I think certainly there's lots of interesting things that can be done from a data point of view. The United Nations Global Pulse Initiative, for example, looks at the Sustainable Development Goals and how these can be supported through technological means, so data science and so on, and some really fantastic examples. But I think those in extreme poverty, I think, they don't live in big data worlds. They live in worlds where there is absolutely no data. There are vast populations of the world where just the basic data of who has been born and who has died isn't even recorded. So I think Industry 4.0 certainly has a contribution to make in the sense that you can bring smart, compact machines that can help people produce things, and you can help those those micro businesses, those entrepreneurs, to do something interesting. But I think those problems are much more entrenched and need very different responses that technology alone can solve. So I'm sure Rupal and Martin have far more interesting things to say than that, but that's just my tuppence worth.
No, it's a really good point, Barry. I think, yeah, absolutely.
I think in terms of, and just in terms of extreme poverty, fortunate enough in Ireland, pockets of extreme poverty are few and far between. And it's not to say they don't exist, by the way, but they are few and far between, and it is a manageable societal problem. It's interesting, particularly in terms of COP26 going on in Glasgow at the moment. The appetite for kind of solving really big problems, and it's actually an interest. Like when we first electrified the state back at the foundations of the state back in the 1920s, the Irish government was prepared to spend 25% of its annual budget on a renewable electrical energy system in Arctic Russia, and is now planning to take on kind of similar challenges again in relation to the kind of money point development that we've got, where we're going to use a lot of kind of offshore wind. We're also going to think in terms of producing natural gas, hydrogen from renewable methods, and we're not spending, like a fraction of what we spent on kind of Arctic Russia at the time. But still, there is this, debate that's going on, nationally now as well. Well, can we afford this type of expenditure? Who's going to pay for it? Ultimately, and to paraphrase Steve Kinsella, who's economist here at the University of Limerick, we can't be just a slave to today's economics. We just have to kind of grapple with these big problems and decide that, as a society, look, we'll pay for them some way, or if we can't pay for them, we'll invent a new economics to pay for them, because ultimately these economic models are ours as well, and particularly when it comes to things like what we can do with the spare capacity in Money Point, that we can become net exporters of energy, we can, help, European energy challenges, but we can also, in the middle of the night, we can also start heating people's homes, and so that we can guarantee minimum standards of living for all our citizens, and that to be a citizen of Ireland and of Europe guarantees you certain services and certain quality of life. And that's the kind of thing where, industrial revolution and modern engineering practices can help. And obviously computers and artificial intelligence, machine learning can help make sure that it's done in a trustworthy fashion. So that's, I think, those are the kind of grand challenges that we just have to realize we have to pay for.
Yeah.
and hopefully in Glasgow this week they'll actually bite that bullet, right?
Sure, absolutely. Yeah, fingers crossed. Rupal, did you want to come in on that question, or?
Yeah, when we talk about extreme poverty and we talk about installing Industry 4.0 or manufacturing units which have this kind of a structure to produce mass production and things like that, we have to focus on revolutionizing the education as well, because people who are in extreme poverty, if we want them to bring them out of it, we need to have education regarding Industry 4.0. We need them to learn about AI, ML, and that's how, yes, we can, in a smaller time, we can bring them out of extreme poverty. But the plan, like what Martin has suggested, so that's a long-term plan that's going to take years before we are so self-sustainable that we can start exporting energy for free. So that's a long-term plan, yeah. But for the shorter term, I think if someone has to get out of extreme poverty, instead of using Industry 4.0 or just establishing manufacturing units there, it's more about, as it is about Industry 5.0, to educate people, to train them. Sorry for the labels, but to train them. So that's how it's possible for bringing people out of poverty, or I'm not sure about extreme poverty, but yeah, it will make them self-sustainable. Yeah.
It's also an interesting bit where artificial intelligence is now being applied to things like intelligent government. So you actually can start defining your terms officially and reliably in terms of what does poverty mean and what does energy poverty mean. Because these things mean different people. It means different things to people living in Limerick City than it does to people living in Calcutta or whatever, sadly, but it does. And to actually have some intelligence applied to what poverty means and to be able to define our terms practically without human bias associated with those decisions being taken. Now, and we can have biased AI systems, so I'm sure Barry will correct me pretty quickly, right? But at least you can call it if you see it, right?
Yeah, absolutely. Yeah, I'm going to be slightly controversial because Martin and Rupal and I are being very agreeable. So the
nothing wrong with that.
I think absolutely nothing wrong with that. But I suppose the other aspect of this, to Henry's question about using Industry 4.0 and so on to is there an opportunity to bring people out of poverty? There's actually a risk of Industry 4.0 and the like bringing people into poverty. And so if you look at the impact of automation in the United States since like 1970, in real, like, productivity levels have gone through the roof. Manufacturing industries are, producing things at lower cost, fantastically well. Productivity is going up, the value is going up. Salaries haven't gone up at all in real terms since 1970. So the ordinary worker in the United States, the ordinary factory worker in manufacturing, hasn't personally benefited at all And in fact, you can easily show that, and there have been many studies that show that, this is the group of people who have, over the last 10, 15 years, have been turned towards the Republican Party, who've been, they tend to be very pro Donald Trump, and I don't want to get very political about matters, but there's a regime that introduced policies that again disadvantaged the factory worker. Mm-hmm. And one could argue, at least one could have a good 3 or 4 hour argument with a bunch of my colleagues that the start of all of that in 1970 was industrial automation and manufacturing, where in a context where everybody wasn't given a share of the benefits. And I think there is a risk with all forms of automation that it does create a potentially larger distance between the haves and the have-nots, because it creates massive value. And what's really important are the policies that we introduce around smart manufacturing to make sure that rising tide raises everybody's boat, because all sorts of things can happen. And I think there is, it's a sort of a slightly odd take on Henry's point, but I think it's one that we do need to be careful about.
And that's an absolutely fair assessment. But it also has to be said that it wasn't AI's decision to exacerbate this gap between the median pay in a company and the kind of pay of your CTO and your CEO. That was capitalism's choice. And so
absolutely.
there are times, particularly as somebody who's interested in machine learning and AI, where I find that I'm defending machine learning and AI, when in actual fact, it's the capitalism who should be actually taking the can here, not the people who are, by the way, being accused of letting the genie out of a bottle, right?
Well, in 1970, we didn't even know there was a thing called NP completeness. So there's a lot of things we didn't know in 1970. Very good.
We have sorry now to interrupt the chat, the conversation, guys, but we've a load of questions after coming in, and I'm just conscious of the time, so we might try and get to one more at least. No, I'm not. I know it's very interesting, but I don't want to.
I know, but it's a funny thing. Germans have got to understand, when the Irish get talking, right?
Yeah. Shutting us up a bit of a challenge.
I have my work cut out for me here. I would be messing. So there's a question here. It's a bit more technical, I suppose. It comes from Emily. So could you go into a bit of detail? I suppose we've mentioned supply chains quite a few times now during the conversation. So could you go into a bit of detail about how Industry 4 could prevent supply chain bottlenecks? She just mentioned here as well that she's thinking specifically about the automotive sector, where just-in-time manufacturing has exacerbated supply chain shortages over the past 18 months, but really applies to any industry. So do you have any input on that, perhaps? I know, yeah, if anyone wants to come in on that.
Well, I suppose the first thing to say is that, obviously nobody expected the impact of COVID-19, right? So it was very difficult, if not impossible, to respond to that. To predict that in a sense, but I think Industry 4.0 techniques can certainly address the kinds of issues that Emily is raising. From a purely analytics and operations research point of view, one can look at one can study warehouse location problems. One can study, there's lots of different inventory problems that one can look at, looking at the extent of demand, the cost of getting things to different locations, I suppose the measures of robustness of getting things to particular locations. I think it's all in the formulation of the problem, in a sense. I think before COVID, in a sense, we wanted to, we were very focused on minimizing overall costs, maximizing efficiency, where these terms had particular meaning. And I think what we really need to do now to address the kinds of, the specific issue that Emily's highlighting is we need to think about how we formulate those objectives. And so, what is the goal? What does robustness mean? What does cost mean? And so in our cost terms, I don't think we would have ever have imagined that, 2 years ago, if you said to a builder, You will not be able to buy screws in the local building supply shop. I think they would think you're crazy. How can this possibly happen? But it happened. There was a shortage of these items. So I think we really have to look at the objective functions that we're using for designing these supply chain systems, and make sure that they are that they do capture all the kinds of things that we've been talking about. And this is really the learning from COVID-19, and we can't go back to how it used to be, because it would simply be the wrong thing to do. Because if we ever find ourselves again in a pandemic-like situation, and maybe it's not a pandemic, maybe it's a war, or maybe it's a natural disaster, or whatever it is, we have to make sure that we're doing the right things in the right places, and that there are supply routes. Just before, as Ireland was opening up, there was a group within the Irish Defence Forces, within the Irish military, that was stood up to start working on designs for face masks that would be distributed to every house in Ireland, so that people could make their own face masks. There was a fear that there would be a global shortage of face masks. And so, we just have to get I think we just have to get the objective functions right. And I don't say and that's going to be an easy thing, but I think that's where we need to start.
Yeah. And it is. Yeah, sorry, Rupal.
No, sorry, go ahead. Sorry, Randy.
No, I mean, it's the one thing where machine learning can help, of course, is that it can make sense of complex pictures much better than humans can. I mean, you think in terms of what complex systems, modern supply chains are hugely interactive and interacting complex systems with thousands, hundreds of thousands, tens of thousands of inputs, so many different outputs, so many different states in the system. The timelines are huge. Making sense of pictures like that sometimes require computers in order to be able to do it. And it's a discipline in itself. Data visualization, graphing, representation, alerting. How can you pick out patterns from hugely complex data maps like that? I mean, these are things that are just beyond human cognition without the assistance of machine learning algorithms. So, the question is to develop the skills of our workforce so that they actually can make sense of the really complicated data sets in a sensible fashion. And so therefore that we can predict that problems are going to happen earlier.
I would like to address Emily's question on a more basic level, because she is asking how Industry 4.0 is going to help us with if there's an oversupply or an undersupply. So what happened was that because there is a shortage of workers, because there's a shortage of population, so most of the manufacturing job is offshored. So it's China, it's India, it's Bangladesh. That's where most of the manufacturing is happening. And what Industry 4.0 does is that you have now robotics, you have robots who can do the same thing that humans are doing at a faster speed. You have the supply chains, which is optimized. You have digital twins to optimize everything. So with Industry 4.0, you can bring back those jobs, because now even if there's a shortage of population, you have robots to help you out with that. So you can help with the supply chain. You can have the number of whatever amount it is, you can have the amount of certain product that you need. So that's how you can curb the problem of undersupply. And oversupply can be curbed by, like Barry and Martin have been discussing, through AI, through machine learning. You can understand what's required, how much it's required, when it's required. So that's how it works. So I just went into the basic of it, how and why, because I wasn't sure if she wants to know the exact reason why Industry 4.0 is important for Europe right now. Yeah.
I see in the question and answer box, just to address Vishram's point as well directly.
Yeah.
I mean, I've long been an advocate of, within the context of the green computing agenda, like for example, for all our proposals that we will present to at Horizon Europe level, that there should be a proper accounting of, the number of floating point operations that are associated with the algorithms that we propose, and that we actually do look at elegant computing solutions rather than just throwing computers at a problem, because there is this culture out there that the pretty solutions. Here, I'm speaking on behalf of the computer scientists here in the audience. The pretty solutions don't matter. Just throw a computer at the problem. Well, if you had, a green computing agenda, then that would matter. And, you know, and particularly in an Irish context now where the cost of holding this data is now becoming a serious concern, and people are talking about, you know, energy brownouts, and in order to be able to kind of house and manage the data centers that we are tasked with operating. This notion of a green computing agenda is more and more important. And I absolutely agree that some type of proper accounting in terms of the algorithms that we develop is essential. And, you know, is something that, if we're serious about climate and sustainability, it's something that we've got to address.
Yeah.
Thanks, Martin. Yeah. So just for those in the audience, that was in relation to, because the audience can't actually see those questions. That was just in relation to a question about manufacturing units of the future. Like, should it be ensured that they're self-sufficient going forward? So thanks, Martin, for your response to that. I suppose we have about 8 minutes left before time. And just one other element I wanted to focus on during the discussion. We probably won't get to all of the questions from the attendees at this point, but was, I suppose, something that was launched in Ireland this year, and that's the national strategy around AI, which was launched in July. I know, Barry, I believe you were had a big part to play in that. But something I noticed from it, and I think it links to the discussion we've had quite well today, even though we were speaking in a more general sense about Industry 4, was that it seems to be very, very people-centric. So across the 3 themes within the strategy, there's a strong focus on people. And so I suppose outside of the domain of production and manufacturing that we've kind of focused on today, I suppose this is specifically in relation to AI now. So how do we see, like, AI having an impact on society as a whole, we'll say, for, you know, on a day-to-day basis?
Yes, so I guess, look, I'm an AI optimist, but at the same time, you know, there are potentially massive challenges. You know, what we've learned from social media companies, obviously, is that the truth doesn't propagate as quickly as the untruth. Lots of issues around bias, gender bias, racial bias, all of these types of things in machine learning systems. And I think it's very important that we ensure that that these types of technologies are human-centric, and that, you know, what that means, that at least from a European point of view, that these systems don't violate, you know, the Charter of Fundamental Rights in Europe and so on. And, you know, not only in Ireland, you're correct that the Irish National AI Strategy is very, very human-centric. It really calls out those values. But this is also true in the European Commission's proposed AI Act. So that AI regulation talks about a risk-based approach to regulating these systems, and risk basically has 2 dimensions. One is the AI system robust, so in other words, does it do what it's supposed to do? And the other dimension is it consistent with, you know, to what extent does it cause harm vis-a-vis the Charter of Fundamental Rights? So it's absolutely important that we address those issues. And of course, you know, I think that's probably, from, you know, I'm not an expert, but that's what I understand from Rupal, who gave me a good tutorial on the difference between Industry 4.0 and 5.0. That this is the key difference. That's, you know, the sort of human-centric and trustworthy dimension to the technology is what's core. But that's really, really important, because I think people are becoming far more aware of the consequences of technology, and they demand trustworthy technology. But I think it would be a mistake to think that AI systems need to be trustworthy. I think we also need to remember that all systems that are algorithmic in nature, regardless of whether they're machine learning based or whatever else, but if they're essentially complex algorithmic methods for making decisions, that these things are human centric. And we need to be very, very precise about what we talk about. You know, the idea of making AI systems or algorithmic systems bias free is actually a mathematical impossibility. There are theorems that you can't do that. You can't make these things bias free, and that's okay, because we deal with bias in the real world by fighting it with bias. You know, so things like you know, ensuring, you know, putting extra efforts into ensure that there's representation on selection committees, you know, affirmative action, these types of things. So, you know, we can fight bias with bias, but I think the human-centric dimension is absolutely critically important.
No, absolutely. And I think that's been really clear from the entire discussion today that that human element, while automation is important, also the human element is equally if not more so. So I don't know if Martin or Rupal, did you want to come in on that last point there, or are you okay?
No, I just saw this question by saying from Confirm about COVID-19 and its impact on smart manufacturing. So
Oh, yeah.
I think it has been the other way around. Actually, smart manufacturing has helped during the COVID-19 time, because especially if you have automated industries and you have minimum human contact, it's going to help. So I just wanted to comment on that. I saw that comment there.
Yeah. I
No
suppose,
problem.
and also to Aideen's points that you made, particularly in relation to the entrenchment of bias in political systems. I mean, you, as you say, I mean, and as Barry points out, one thing about cognitive governments and the use of machine learning in government is that you can overcompensate. You can overshoot the set point in response to something being wrong. And if you do that, then things will happen more quickly than if you decide to approach a set point from below. And that's a decision that you can instruct a control law to take. And again, it will be up to human beings in order to set the ground rules for that system to behave in practice. So ultimately, it will be humans who'll be at the wheel, right?
I think everyone hopes for that.
Yeah, I noticed, Sean, that there's one question that at the end there from Vishwam about universal basic income, and he asks, would the universal basic income become a global necessity in this industrial X.0 future? And the short answer is yes. Absolutely.
Brilliant.
Well, if we have our way, anyway.
Yeah, exactly.
We have our way, yeah.
So we're nearly at time, everybody. So I think we might leave it at that for today. So before you go, I'm just going to pop a link into the chat there. So we'd really appreciate it if all the attendees could take a moment to fill out the questionnaire at that link. Before we finish up, I'd like to sincerely thank the panel for your input today. It was a really, really interesting discussion. So thanks, Rupal, Barry, and Martin. And I'd also like to thank all of everyone in the audience for attending, and we hope you enjoyed the discussion. So I'm just going to share quickly with you, if I can get my screen working, and just some contact information for Confirm. So if you want to keep up to date on any upcoming events that we put on, our social media handles are there. Finally, I'd just like to thank Berlin Science Week for having us, and I'd also like to thank the Irish Embassy in Berlin for their assistance in organising the event. We hope you enjoyed it, and we hope you found it informative. So that's it from us. So thank you very much for attending, and take care.